So I was saying that we have two myofibrils here which we want to use. Let's assume that they were adjacent to each other. Adjacent, I mean close to each other. For example, this one, let's just draw a line here. This one's here. So assuming that these two we have pulled out, this is 1 and this is 2. If they were adjacent to each other like this one's here, then the light band, this light band here of this myofibril would be on the same line, would lie adjacent to the light band of the next one. Because of that, it now produces a continuous light band, this one here, the continuous light band which you see in the whole muscle fiber. Remember, these were just light bands in the myofibril, but because they are continuous with each other, they now produce this continuous light band on the muscle fiber. Then the dark bands of this myofibril will be on the same line with the dark band of the next adjacent one, and will be on the same line with the next adjacent one, like that, to form now this continuous dark band here. That's what we mean by this statement. That the light and dark bands are adjacent to each other, or they lie side by side to each other. Now, because of that, they produce those continuous light and dark bands, which we call the striations or the strips, the stripes in the entire muscle fiber. Good. Now, what really brings in, what causes these dark bands and light bands which we are talking about? The cause of these two bands are the two proteins. The proteins are the actin filaments, which are thin. Note that. Very important. The actin filaments are thin. And then the myosin filaments, which are thick. So, let's try to think about this as pieces of paper. Actin filaments as very thin pieces of paper that you can even see through it. Then the myosin filaments as very thick pieces of paper that you cannot easily see through it. But of course, you can somehow see through it. It is not so thick. Now, if you have only the thin piece of paper in one place, can you see through it easily? I think it will appear light because it is thin. Light can easily penetrate it. You can see as if it is light. Then, if you have the thick one alone, it will not be very visible, but at least you can see some light through it. What if you combine the thick and the thin? It will now look dark. It will look dark. That is the concept we are going to use here. So, the light band, which is also called the I band, contains only, and the word is only, the thin actin filaments. So that is why it is a light band, because it has thin actin filaments which appear thin. They appear light. Light can pass through them. You can see through them. The actin filaments are in the light band. It is only the actin filaments there. Then the dark band has two regions. There is a region in the middle of the dark band which is somehow lighter. It is comparatively lighter compared to the other regions in the dark band. And that region, of course, is in the middle of the dark band. We call it the H region. We call it the H zone. The H zone contains only the thick myosin filaments. Remember, we said the thick piece of paper is thick, but at least you can see some light through it. That's why it appears somehow light. So if you go back to this drawing here, this is of course the thick, rather the dark zone. From here up to here is the dark zone. The dark band, not the dark zone. So in the middle of this dark band, we see this somehow lighter middle zone. That light middle zone, this one here, is the one which we call the H zone, not the H line. It is the H zone. Okay? Then on either sides of this H zone, on this right side and also on the left hand side, there are two darker regions of the dark zone. Those ones contain both the actin filaments and the myosin filaments. So this is what we are talking about. So the H zone contains only the thick myosin filaments. They are thick, but at least you can see through them. Then, on either sides of the H zone, we saw the two dark zones. We saw the two dark regions. And of course, we said that the two dark regions on either sides of the H zone are composed of both the myosin filaments, which are thick, and the actin filaments, which are thin. So we said, remember, if we have our pieces of paper, one is thin, the other one is thick, and then we put them together, now you cannot easily see through them. It is now dark there. Okay? That is the analogy. So the region which is too dark contains both of these, the thick and the thin filaments. Great. So in the middle of the H zone, remember what the H zone is? Is a somehow light zone in the middle of the dark band. So in the middle of the H zone, there is a line, a thick line, which is dark. There is a thick line which runs through the middle of the H zone. We call it the M line. Call it the what? The M line. Then in the middle of the light band, the light band, there is a dark line, very dark line, which is called the Z line. So if we can go back, you see the whole of this from this point up to this point, the whole of this is the light band. Now, in the middle of this light band, you see this line here, this thick line here, this thick line. Even here, from here up to here, is the light band. But in the middle, we see this line here, the dark one. That line is called the Z line. Okay? Now, the region between two successive or two adjacent Z lines, the region between two adjacent Z lines is called the sarcomere. What is the sarcomere? It's the region between two adjacent Z lines. Let's try to see it here. So where is the first Z line? This is the Z line here. This is one Z line. Then there is another Z line here. So the region between these two, from this point up to this point, is what we call the sarcomere, between two adjacent Z lines. If there was another Z line here, for example, if this was another Z line, then the region between this Z line, this side, and this one here would still be another sarcomere. So what is the sarcomere? It's the region between two